Hello and welcome to Add-on. So today we have this numerical based on the topic of Miller indices. So our task is to determine the Miller indices of a specific plane that is parallel to the z-axis and has certain intercepts along the x and the y-axis. So the question says, determine the Miller indices of plane parallel to the z-axis and cut intercept of 2 and 2 by 3 along x and y-axes respectively. So we will solve this step by step. So first of all, what does it mean for a plane to cut along an axis? So when we say a plane cuts an axis, suppose this is the x-axis and this is the y-axis, and here we have 2, say. So if a plane cuts the x-axis at this point 2, then the point where it intersects x is at 2 units long. Now in our question, the intercepts along x and y are 2 and 2 by 3 respectively. But what about the z-axis? Well, the plane is parallel to the z-axis, so it never intersects it. So we can think of this intercept as being at infinity, right? So let's write down the intercepts. What do we have here? Intercepts. So the intercepts we have are 2a, 2 by 3, and infinity along z-axis. But what is this a and b? Here a and b are the basic unit distances along the x-axis and the y-axis, but we will just work with the numbers directly. So why do we need fractional intercepts? So to find the Miller indices, we convert these intercepts into a fractional form. But why? Why do we need fractions? Because this fractional triplet represents how far each axis is cut. So for x we have 2, and for y-axis, along y-axis we have 2 by 3, and for z we have infinity since it is parallel and does not cut z. So we will write infinity. So now let's take the fractional triplet. So our fractional triplet are the coefficients of the intercepts, which is 2 along x-axis, 2 by 3 along y-axis, and infinity along the z-axis. But then why do we need reciprocals in finding the Miller indices? Why do we need it? So Miller indices are defined by reciprocals of these intercepts because it standardizes the way we express planes, as Miller indices are used to express what? Orientation of the plane along the axes. So taking the reciprocal of each intercept gives us a new set of values that tells us how the plane is oriented along the axes. So let's take the reciprocals. Reciprocals. What is the reciprocal of 2? It's 1 by 2. And for 2 by 3, the reciprocal is 3 by 2. And what is the reciprocal of infinity? What is 1 by infinity? Well, 1 by infinity is 0, right? So we will write 0. Now here comes our final step. How will we get clear fractions? These are fractional, right? So to get clear fractions, we do this by finding the least common multiple of the denominator, the LCM of the denominators. And what is the LCM of 1 by 2, 3 by 2 and 0? Yes, it's 2. So we will multiply each of this with 2. So 1 by 2 multiplied by 2, 3 by 2 multiplied by 2, 0 multiplied by 2. So we will cancel 2 by 2 and 2, 2 and 2. And anything multiplied by 0 is 0, right? So we have 1, 3, 0. So this is our Miller indices. This gives us the Miller indices as 1, 3, 0. So let's recap how we solved it. So we started with the intercepts, which are 2a, 2 by 3b, and infinity, and then converted them into fractional triplets, which is 2, 2 by 3 and infinity. And after that, we took the reciprocals, which are 1 by 2, 3 by 2, and 0. And after that, we multiplied them with the LCM of the denominator, which is 2 in this case. And after calculating, we obtained that the Miller indices are 1, 3, 0. That's it. There we have our Miller indices. Thanks for watching. And you may apply the same steps for solving the problems of Miller indices for any set of problems. Thank you.